You believe you know what touching something feels like. You reach for a table, press your palm against it, and the experience seems immediate and obvious. Skin meets wood, contact happens. End of story. This assumption feels so basic that it never earns suspicion. Touch appears to be the most honest of senses, the one that confirms reality when sight or sound might mislead. Yet that confidence is precisely why the illusion survives unnoticed. Consider how rarely you pause to think about what touch actually is. You do not ask how two objects meet. You do not wonder what happens in the instant your hand stops moving. You simply accept the sensation and move on. Everyday life depends on this acceptance. Without it, every action would feel uncertain, delayed, or incomplete. The world would feel unreliable in a way that makes ordinary living impossible. But physics has an uncomfortable habit of taking the most familiar experiences and quietly removing their foundations. When examined carefully, touch begins to look less like contact and more like negotiation. Something pushes back, something resists. Yet nothing obviously meets. The certainty dissolves the moment you ask a simple question. What exactly is stopping your hand? At first, the answer feels trivial. The table stops you because it is solid. Solids are made of matter, and matter occupies space. Two things cannot be in the same place at the same time. That explanation works well enough to get through childhood and most of adulthood. It is simple, intuitive, and wrong in a way that only becomes visible when you slow down. If you were allowed to shrink and watch this moment closely, you would not see surfaces colliding. You would not see edges touching. Instead, you would find emptiness on a scale that feels almost insulting. Space inside space, distance where solidity was promised. The table, which felt firm and undeniable a second ago, would appear strangely hollow. This is where the illusion tightens its grip. Your senses insist that something firm exists where your hand stops. Your experience confirms it repeatedly. Yet the closer you look, the less contact you can find. What you feel is real, but what you think it represents is not. Touch delivers a message, but it disguises the sender. Richard Feynman loved these moments, not because they confuse people, but because they reveal how deeply human intuition relies on shortcuts. We evolved to navigate surfaces, not to inspect them. Our brains report outcomes, not mechanisms. They tell us that motion has stopped, pressure is felt, and action is complete. They do not tell us why. This gap between experience and explanation is where the illusion lives. Touch feels final, but it is only the result of something more subtle happening beneath awareness. You are not feeling contact. You are feeling a boundary enforced by rules you never agreed to and never noticed. The moment you accept this, the question shifts. If nothing truly touches, what is the world actually made of? This realization is unsettling because it undermines trust in direct experience. If touch can mislead, then certainty becomes fragile. The world does not present itself as it is, only as it needs to be perceived for survival. Physics steps in not to deny experience, but to explain its limits. What you feel is consistent, useful, and convincing. Yet it is a translation, not a transcript. The deeper story waits beneath the sensation, patient and invisible. It is there every time you press your hand forward, quietly refusing actual contact, forever unseen. When your hand approaches a table, nothing dramatic appears to happen. There is no spark, no visible barrier, no warning sign announcing that reality is about to intervene. Yet long before your skin arrives anywhere near the table's atoms, the interaction has already begun. The moment feels delayed only because your senses compress events into a single experience. Physics does not. Atoms are not miniature billiard balls stacked neatly together. They are mostly empty space structured around electric charges that never truly rest. At the center sits a dense nucleus, while electrons occupy regions defined by probability rather than position. These electrons do not orbit like planets. They exist as clouds, spread out, restless, and governed by rules that defy everyday logic. As your hand moves closer, the electrons in your skin encounter the electrons in the table, not through contact, but through influence. Like charges repel, this rule is absolute. It does not negotiate. The electrons in your hand resist being forced into the same quantum states as the electrons in the table. That resistance is what you feel. No atom ever collides in the way intuition suggests. Instead, electric fields push back. Forces rise sharply as distance shrinks. The closer the electrons are forced, the stronger the repulsion becomes. Your hand slows, then stops, not because it touched something, but because it was prevented from moving further. Motion ends without contact ever occurring. This interaction happens astonishingly fast. The forces involved propagate at near light speed. By the time your brain registers pressure, trillions of electrons have already adjusted their configurations. Your nervous system receives a summary, not a report. It tells you that something solid exists where your hand cannot pass. What you interpret as hardness is simply resistance to compression. Materials feel different because their atomic structures respond differently to being forced closer together. A pillow yields easily because its atoms are arranged in a way that allows movement and reconfiguration. A table resists because its structure tightly constrains motion. Both are governed by the same rules. Only the arrangements change. Temperature, texture, and firmness are all side effects of atomic behavior. Warmth is motion. Roughness is variation. Pressure is force distributed across countless interactions. None of these sensations require atoms to touch. They only require forces to act. This is where the illusion becomes complete. Your brain was never designed to perceive fields or forces. It evolved to interpret patterns that mattered for survival. So it translates resistance into solidity, repulsion into contact, and absence into presence. The translation works so well that questioning it feels unnatural. Feynman emphasized that this does not make reality less real. It makes it more precise. The universe operates through rules that do not care how they feel to us. Touch is not a fundamental interaction. It is an emergent experience, assembled from electric forces, quantum restrictions, and biological interpretation. Once you see this, the world changes texture. Every surface becomes a zone of influence rather than a boundary. Every solid object becomes a dynamic system holding itself together through balance, not contact. You move through a universe that never allows things to truly meet, only to push back just enough to keep the illusion alive. This perspective also explains why damage, friction, and pain occur without atoms ever crossing paths. When forces become intense enough, bonds rearrange, structures fail, and energy transfers violently. Skin tears, materials break, and heat spikes, not because matter overlaps, but because the balance holding atomic systems together is disrupted. What feels like impact is actually reorganization under stress. Even at the microscopic level, nature avoids true contact, substituting interaction for intersection. The universe enforces boundaries, not with walls, but with rules. Every object you encounter is upheld by invisible agreements between charges and probabilities, continuously renegotiated as you move. Touch, then, is not an exception to emptiness. It is emptiness expressing its limits, reminding you that solidity is a sensation, not a fact. Understanding this reshapes intuition, replacing naive contact with layered interaction, where reality resists intrusion through fields, constraints, and relentless physical law operating everywhere, always without exception or mercy. Your brain did not evolve to show you the truth. It evolved to keep you alive. That single fact explains almost every illusion you experience about reality, including the sensation of touch. The brain is not a scientific instrument. It is a survival interface designed to compress an impossibly complex universe into something fast, simple, and usable. At the microscopic level, reality is chaotic, abstract, and deeply unintuitive. Forces act without contact. Objects are mostly empty space. Events happen faster than thought. If your brain tried to present this raw version of the world, you would be paralyzed. Decision making would collapse under detail. So the brain lies constantly, efficiently, and without apology. When electric forces repel your hand from a surface, your brain does not report electromagnetic field interaction preventing further motion. It reports solid object. That translation is not an error, it is a feature. The brain replaces invisible causes with stable concepts you can act on instantly. Solidity is one of those concepts. This process happens automatically. Sensory nerves detect pressure, deformation, and vibration. These signals are crude and incomplete. The brain fills in the rest using prior assumptions about how the world should behave. If the pattern matches expectations, the illusion is seamless. You never notice the gap between physics and perception. Feynman often pointed out that we mistake the map for the territory. What you experience is a model, not reality itself. Touch feels direct, immediate and undeniable, which makes it easy to assume it reflects the world as it truly is. But feeling convincing does not mean being accurate. Dreams feel real too until you wake up. The brain simplifies because it must. There is no time to calculate quantum forces while catching a falling object. There is no advantage in perceiving probability clouds instead of edges. Evolution rewards speed, not precision. A brain that pauses to question the nature of contact does not survive long enough to pass on its gene. Touch is one of the strongest illusions because it carries emotional weight. It signals safety, danger, closeness, and control. The brain protects this signal fiercely. It will not allow ambiguity where certainty is required, so it insists that you touch the table even though nothing truly met. Once you accept this, a deeper realization follows. You are not experiencing the universe. You are experiencing a story about the universe, told inside your skull. In real time, the story works remarkably well. It lets you move, build, and survive. But it is still a story. Physics reveals the rules beneath the story, not to invalidate experience, but to humble it. The brain lies because it must, and because the truth would be useless in daily life. The universe does not feel like fields and forces. It feels like hands and walls. That feeling is not reality itself. It is reality translated into a language your nervous system can understand, whether or not that language is honest. Richard Feynman's real insight was never about touch itself. Touch was just the doorway. The deeper point was far more unsettling. Nothing in the universe is defined by what it is, only by how it interacts. Contact is a story we tell. Interaction is what actually happens. In everyday language, we describe the world in terms of objects. Tables, hands, walls, particles. We imagine them as things with boundaries, surfaces, and locations. But physics does not work that way. At the fundamental level, the universe is not made of objects pressing against each other. It is made of interactions governed by rules. When your hand approaches a table, nothing waits at the surface to be touched. What exists are electric fields extending outward from atoms long before anything appears solid. These fields do not mark edges. They simply influence other fields. When two regions of influence overlap strongly enough, motion changes. That change is what you interpret as contact. Feynman emphasized that asking what something really is often leads nowhere. Physics advances by asking what does it do and how does it interact. Electrons are not tiny balls. Light is not a substance flowing through space. Even particles themselves are better described as events than objects. Their identities come entirely from how they affect other things. This reframes the idea of reality itself. If nothing has intrinsic solidity, then the world is not built from hard pieces assembled together. It is built from relationships. Every measurable property, mass, charge, position, only exists in interaction with something else. Remove interaction and the concept loses meaning. But it is governed by the same principles as gravity, magnetism, and light. No privileged channel exists where matter suddenly becomes real. The same forces that keep electrons in atoms also prevent your hand from passing through a table. The difference is scale, not kind. What makes this difficult to accept is how language misleads us. Words like surfaces and boundary suggest sharp divisions. Physics offers none. Fields fade gradually, probabilities spread, effects overlap. The universe does not draw lines where we expect them. Our senses do. Feynman often warned that intuition built from everyday experience fails badly when applied to fundamental reality. Evolution shaped intuition for throwing rocks, not for understanding fields. So when physics tells us that solidity is an illusion and that contact never occurs, intuition rebels. It feels wrong because it was never designed to feel right. The idea that reality is interaction also dissolves the sense of separateness. Objects are not isolated entities bumping into each other. They are knots in a web of influence, constantly exchanging energy, momentum, and information. The table affects your hand just as much as your hand affects the table. There is no clear direction of action. This view also explains why physics does not talk about absolute properties. There is no absolute rest, no absolute time, no absolute position. Everything is defined relative to something else. Even existence, in a measurable sense, requires interaction. What cannot interact cannot be detected, and what cannot be detected cannot be said to exist in any meaningful physical way. Once you accept this, Touch loses its mystery and gains a new strangeness. You were never pressing against matter. You were participating in a negotiation between fields. The sensation of resistance was the universe, enforcing its rules locally, moment by moment. Feynman's deeper point was not meant to strip meaning from experience. It was meant to reveal how extraordinary ordinary experience actually is. Every time you rest your hand on a table, you are witnessing countless invisible interactions, aligning perfectly to create stability. The illusion works so well that you forget it is an illusion at all. Reality at its core is not about contact. It is about interaction. And you are not a solid thing moving through a solid world. You are an ongoing process, interacting continuously with other processes, held together not by touch, but by the silent agreement of physical laws. Once you accept that touch is an illusion, and reality is built from interactions, the question is no longer about tables and hands. It turns inward. What does this mean for you? For your body, for your sense of being a solid self moving through a solid world. Your body feels permanent, bounded, and clearly defined. But physically, it is no different from the table you cannot truly touch. It is a temporary pattern of interactions held together by forces, fields, and probabilities. The atoms in your body are not fixed possessions. They are constantly exchanged with the environment within a few years. Most of them will be gone, replaced by others, while the pattern remains. You experience yourself as a stable object because your brain tells the same story repeatedly. Continuity is a narrative, not a physical requirement. Physics does not recognize you as a single thing. It recognizes processes, chemical reactions, electrical signals, energy transfers. The sense of a unified self emerges from coordination, not from substance. This realization can feel unsettling, even threatening. If you are not a solid object, what are you? The instinctive fear is that illusion implies meaninglessness. But Feynman's worldview points in the opposite direction. If everything is interaction, then existence is not diminished. It is intensified. You are not isolated, you never were. Every moment your body is interacting with the rest of the universe. Gravity pulls you toward Earth. Electromagnetic forces hold you together. Radiation from distant stars passes through you without notice. The boundary between you and not you is practical, not fundamental. Even pain and pleasure take on a different meaning. They are not signals of contact, but signals of interaction strength. When forces change too rapidly or intensely, your nervous system reacts. Pain is not the universe hurting you. It is your brain warning you that the pattern is being disrupted. This perspective also reframes control. You do not manipulate a world of objects from the outside. You influence systems you are already embedded in. Every action is a mutual adjustment. When you push on something, it pushes back, not because it resists you, but because the rules demand balance. Newton's laws are not suggestions. They are constraints that apply to everything equally. Feynman loved this idea because it removed the illusion of human exceptionalism without stripping away wonder. You are not separate from physics. You are an expression of it. The same principles that govern galaxies govern your heartbeat. The same forces that prevent your hand from passing through a table allow you to exist at all. There is also a quiet humility in realizing how much of reality you never experience directly. What you perceive is a thin slice of what exists, filtered for survival. Yet even that slice is astonishingly rich. The fact that such a limited interface can support curiosity, creativity, and self-reflection is remarkable. Understanding that touch is an illusion does not make life colder. It makes it stranger, deeper, and more fragile. Every stable thing you rely on is the result of countless interactions continuing without interruption. Stability is not guaranteed. It is maintained, and perhaps the most profound implication is this: certainty is a feeling, not a fact. The world feels solid, dependable, and obvious. Physics shows that beneath that feeling lies constant motion, uncertainty, and negotiation. You live on the surface of a storm you cannot sense. Feynman never asked you to abandon common sense. He asked you to hold it lightly. Use it to live, but not to define reality. The universe does not owe you intuition. It only follows its rules. You may never actually touch anything, but you are always interacting. And in that endless exchange between forces, fields, and fragile patterns, your existence is not less real. It is more astonishing than it ever felt before.